Right.
And you get a better power law graph in your data, right?
When you do that, yeah.
Right.
And we mean better that you use the old method. But the method is wrong.
But the data itself, the graph itself looks better indeed. It looks better.
What? The log plot?
The log plot.
Yeah, but no, it's wrong because this has a power law, but this one has a different exponent, so it shouldn't be a power law.
I know, but in the experiment, how do I know it's different piece of paper? I mean,
You don't know, so that's right. So you have to use AIC. That's the message.
But how do I know the AIC? Because I don't know the fitting parameter.
No. AIC is a ready. It's a method. Okay, you just use a method, and you have to tell it that we have a data. I want to compare power law and double power law and some other law. You take these three different models, and you calculate their AIC value, and you compare which one is the smallest. So AIC will say, the smaller one is the better one. So as long as you have a set of data, raw data, and you tell me what fitting function you suspect, what candidate you have, then you use the method, you can calculate a value for each model, and you just pick the smallest one. Okay, so you need to have a candidate. Then you say, what happens if I pick a wrong candidate? And so sort of I'm comparing a wrong candidate. So statistically, we said there's nothing we can do. We cannot tell you the correct model. We can only tell you the better model. So you have to tell me what model you're competing, and it can rigorously tell you which one is better over the other one. But there's no guarantee this better one is ultimately the correct one. No, it cannot tell you. Right. So that means
empirically, because we don't know the true physics, but empirically, just using power law itself give the better fitting to the separate.
Yeah, that's right. But that you're using your eye. So for AIC method, that means you should check double power law, because we just proved that double power law is very close to the single power law in the phase space. So you need to check double power law. And if you read our paper, we also propose there's a exponential with a cutoff. There's about 3 or 4 candidates that are, when you put a log plot, they all look very similar to a straight line. So there are a few candidates that you should check. When you plot a log, if you look like straight, there are about 5 or 6 power law, 6 different law you should check. But so far people didn't do that. They love power law because power law can get to the nature and science. So they just simply say it's a power law. They didn't bother to check the statistics. So that's a message. You shouldn't do that. Okay, you do a better job.
More questions? Okay, so let's thank our speaker again. Okay, for his interesting talk.